To determine the derated ampacity of a 500 mcm mineral-insulated cable when its terminations are only rated for 75 degrees C, one must follow a specific procedure outlined by the National Electrical Code, commonly referred to as the NEC. This process involves applying temperature correction factors to the cable's ampacity found in NEC Table 310.16, which is based on a 90 degrees C rating for the cable itself. However, because the terminations are only rated for 75 degrees C, one must adjust the ampacity to ensure compliance and safety. The initial step involves locating the appropriate temperature correction factor. The NEC Table 310.15. B2 provides temperature correction factors for conductors based on their insulation temperature rating and the ambient temperature. For copper conductors with a 75 degrees C insulation rating, one must find the correction factor that corresponds to the specific ambient temperature in which the cable will be installed. In this scenario, the NEC Table 310.15 B2 lists the temperature correction factor as 0.82. This value will be used to adjust the ampacity of the 500 mcm cable. Now that the temperature correction factor is determined, the next step is to calculate the adjusted ampacity. This is done by multiplying the ampacity listed in NEC Table 310.16, which is 430 amps for 500 mcm cable rated at 90 degrees C, by the temperature correction factor. So, the calculation would be as follows: adjusted ampacity equals table ampacity times temperature correction factor. Substituting the values, one has adjusted ampacity equals 430 amps times 0.82. Performing this calculation gives an adjusted ampacity of 353.6 amps. Therefore, the derated ampacity of the 500 mcm mineral-insulated cable, when using 75 degrees C terminations, is 353.6 amps. This value must be used for designing the circuit, selecting appropriate overcurrent protection devices such as circuit breakers or fuses, and choosing other equipment and devices that will be connected to the cable. It is crucial to adhere to this derated ampacity to prevent overheating of the terminations and potential electrical hazards. In summary, the process involves firstly identifying the table ampacity of the cable at its rated temperature, which is 430 amps at 90 degrees C for a 500 mcm mineral-insulated cable. Secondly, determining the temperature correction factor from NEC Table 310.15. B2 based on the termination temperature rating, which is 75 degrees C, and the ambient temperature. In this instance, the temperature correction factor is 0.82. Thirdly, calculating the adjusted ampacity by multiplying the table ampacity by the temperature correction factor. In this case, 430 amps times 0.82, which equals 353.6 amps. Finally, using the derated ampacity of 353.6 amps for circuit design and equipment selection to ensure safety and compliance with the NEC. It is imperative to note that this derating procedure is in accordance with the NEC guidelines and is essential for ensuring the safe and reliable operation of electrical systems. Failing to properly derate cable ampacity can lead to overheating, insulation degradation, and potentially dangerous electrical faults. When designing electrical circuits, always consult the latest edition of the NEC and follow all applicable requirements and recommendations. Additionally, it is important to consider other factors that may affect cable ampacity, such as conduit fill, grouping of conductors, and ambient temperature, and adjust the ampacity accordingly. Electrical codes and standards are in place to protect people and property from electrical hazards, and it is the responsibility of electrical professionals to adhere to these codes and standards. Always consult with a qualified electrical engineer or inspector if you have any questions or concerns about electrical installations or calculations. The NEC provides comprehensive guidelines for electrical installations, including requirements for conductor ampacity, overcurrent protection, grounding, and wiring methods. It is important to stay up to date with the latest edition of the NEC and understand the applicable requirements for each specific installation. Proper electrical design and installation practices are essential for ensuring the safety and reliability of electrical systems. By following the NEC guidelines and consulting with qualified professionals, one can minimize the risk of electrical hazards and create a safe and efficient electrical environment. In addition to temperature correction factors, there are other factors that can affect cable ampacity. These include, firstly, the number of current-carrying conductors in a raceway or cable. When multiple conductors are grouped together, the heat dissipation capability is reduced, and the ampacity must be derated accordingly. Secondly, the ambient temperature. High ambient temperatures can reduce the cable's ability to dissipate heat, and the ampacity must be derated to compensate. Thirdly, the type of insulation. Different insulation materials have different temperature ratings, which affect the cable's ampacity. Fourthly, the installation method. The way in which the cable is installed, such as in free air or in a conduit, can affect its ability to dissipate heat. To account for these factors, the NEC provides ampacity adjustment factors and correction factors that must be applied to the cable's ampacity. It is important to carefully consider all of these factors when designing electrical circuits and selecting cables. The derated ampacity should always be used for selecting overcurrent protection devices and other equipment. Failure to properly derate cable ampacity can lead to overheating, insulation failure, and potentially dangerous electrical faults. Therefore, it is essential to follow the NEC guidelines and consult with qualified electrical professionals when designing and installing electrical systems. Furthermore, the type of load connected to the cable also plays a crucial role in determining the appropriate ampacity. Continuous loads, which are loads that operate for 3 hours or more at a time, require a higher ampacity rating than non-continuous loads. The NEC specifies that the overcurrent protection device for continuous loads must be rated at not less than 125% of the continuous load current. This means that the cable ampacity must be sufficient to handle the increased current demand. Similarly, for motor circuits, the NEC provides specific requirements for conductor ampacity and overcurrent protection. Motor starting currents can be significantly higher than the motor's full load current, and the conductors must be sized to accommodate these high starting currents. Additionally, the overcurrent protection device must be selected to protect the motor from overload and short-circuit conditions. In summary, determining the appropriate cable ampacity involves considering various factors, including temperature correction, conductor grouping, ambient temperature, insulation type, installation method, load type, and motor starting currents. The NEC provides comprehensive guidelines for addressing these factors and ensuring the safe and reliable operation of electrical systems. It is important to consult the NEC and work with qualified electrical professionals to ensure that all electrical installations are in compliance with the applicable codes and standards. By following these guidelines, one can minimize the risk of electrical hazards and create a safe and efficient electrical environment. In addition to the above considerations, it is also important to ensure that the cable terminations are properly installed and maintained. Loose or corroded terminations can create excessive heat, leading to insulation failure and potentially dangerous electrical faults. Therefore, it is essential to use the correct tools and techniques when installing cable terminations and to periodically inspect and tighten the terminations as needed. Furthermore, the cable itself should be protected from physical damage. Cables that are exposed to mechanical stress, abrasion, or chemical exposure can be damaged, leading to insulation failure and electrical faults. Therefore, it is important to protect cables from these hazards by using appropriate raceways, conduits, or other protective measures. Finally, it is important to keep accurate records of all electrical installations, including cable ampacities, conductor sizes, overcurrent protection device ratings, and other relevant information. These records can be valuable for troubleshooting electrical problems and for ensuring that the electrical system is properly maintained. In conclusion, determining the derated ampacity of a 500 mcm mineral-insulated cable with 75 degrees C terminations is a critical step in ensuring the safety and reliability of electrical systems. By following the NEC guidelines, considering all relevant factors, and working with qualified electrical professionals, one can minimize the risk of electrical hazards and create a safe and efficient electrical environment. Proper electrical design, installation, and maintenance practices are essential for protecting people and property from electrical hazards and for ensuring the long-term performance of electrical systems. Remember that electrical codes and standards are constantly evolving, so it is important to stay up to date with the latest requirements and recommendations. Continuing education and training are essential for electrical professionals to maintain their knowledge and skills and to ensure that they are providing safe and compliant electrical services. By investing in education and training, electrical professionals can contribute to the safety and well-being of the community and help to prevent electrical accidents and injuries. Furthermore, it is important to promote a culture of safety in the workplace and to encourage all employees to follow safe work practices. Regular safety meetings, training sessions, and inspections can help to identify and address potential hazards and to prevent accidents from occurring. A strong safety culture can help to create a safe and healthy work environment and to protect employees from injuries and illnesses. In addition to following safe work practices, it is also important to use appropriate personal protective equipment, or PPE, when working with electricity. PPE can help to protect employees from electrical shock, burns, and other injuries. Common types of PPE for electrical work include rubber gloves, insulated tools, safety glasses, and arc-rated clothing. It is important to select the appropriate PPE for the specific task and to ensure that the PPE is in good condition and properly maintained. Finally, it is important to remember that electricity is a powerful and potentially dangerous force. Always treat electricity with respect and follow all safety precautions. If you are not qualified to perform electrical work, do not attempt to do so. Instead, contact a qualified electrical professional who can safely and competently perform the work. By following these guidelines, one can minimize the risk of electrical hazards and create a safe and efficient electrical environment for everyone. And always remember that electrical safety is everyone's responsibility. Be aware of the potential hazards and take steps to protect yourself and others. By working together, we can create a safer and more reliable electrical system for all. The derating of cable ampacity is a fundamental aspect of electrical engineering and is crucial for ensuring the safety and longevity of electrical installations. The NEC provides a comprehensive framework for calculating ampacity derating factors, taking into account various environmental and installation conditions. These factors are designed to protect electrical conductors from overheating, which can lead to insulation degradation, equipment failure, and potentially hazardous situations such as electrical fires. The temperature correction factor, as previously discussed, is one of the most common derating factors applied to cable ampacity. This factor accounts for the ambient temperature surrounding the conductor, as well as the conductor's insulation temperature rating. When the ambient temperature exceeds the conductor's rated temperature, the conductor's ability to dissipate heat is reduced, and the ampacity must be derated accordingly. Another important derating factor is the adjustment factor for the number of current-carrying conductors in a raceway or cable. When multiple conductors are grouped together, the heat dissipation capability is reduced, and the ampacity must be derated to compensate. The NEC provides tables that specify the adjustment factors based on the number of conductors in the raceway or cable. These adjustment factors can significantly reduce the ampacity of the conductors, especially when a large number of conductors are grouped together. In addition to temperature and conductor grouping, other factors that can affect cable ampacity include the type of insulation, the installation method, and the presence of harmonic currents. Different insulation materials have different temperature ratings and heat dissipation capabilities, which can affect the cable's ampacity. The insulation method, such as whether the cable is installed in free air or in a conduit, can also affect its ability to dissipate heat. Harmonic currents, which are non-sinusoidal currents that can be generated by electronic equipment, can also increase the heating of conductors and require ampacity derating. The NEC provides guidelines for addressing these factors and ensuring that the cable ampacity is properly derated. In addition to the NEC, other industry standards and guidelines may also provide information on cable ampacity derating. These standards may be specific to certain types of equipment or installations and should be consulted as appropriate. When designing electrical systems, it is important to carefully consider all of the factors that can affect cable ampacity and to ensure that the ampacity is properly derated. This will help to prevent overheating, equipment failure, and potentially hazardous situations. It is also important to regularly inspect electrical installations to ensure that the cables are in good condition and that the ampacity is still appropriate for the application. Changes in the ambient temperature, the number of conductors in the raceway, or the type of load can all affect the cable ampacity and may require derating adjustments. By following these guidelines, one can ensure the safe and reliable operation of electrical systems and protect people and property from electrical hazards. In conclusion, the derating of cable ampacity is a critical aspect of electrical engineering that requires careful consideration of various factors, including temperature, conductor grouping, insulation type, installation method, and harmonic currents. The NEC provides a comprehensive framework for calculating ampacity derating factors and ensuring that electrical conductors are properly protected from overheating. By following the NEC guidelines and consulting with qualified electrical professionals, one can minimize the risk of electrical hazards and create a safe and efficient electrical environment.